For the Climate Discussion Nexus, I'm John Robson, and in this fact-check video, we're going to go through the top 10 key facts about climate change that you've probably never been told, at least not by the politicians, the activists, or the mainstream media. And coming in at number 10...
We're in an ice age, in a relatively cold interglacial period. Here's a graph from the US government's climate.gov website showing average global temperatures for the past 500 million years. The horizontal gray line shows the average temperature needed for the polar ice caps to melt. Technically, being in an ice age means being below that line, with permanent ice at one pole, or some say both. For most of history, the world was above that line and warmer than today. Scientists think there were a couple of ice ages in the very distant past, before the Cambrian explosion of complex multicelled life just over 500 million years ago. But the most recent period when the world was persistently cold enough to sustain polar ice before the present was about 360 to 260 million years ago, before dinosaurs ruled the Earth. The same thing happened starting again about 40 million years ago if you count ice at just one pole, the South, or 2.6 million if both poles. And we're still in that ice age today.
Here's the last 500,000 years up close. The long cold periods that you see are called glaciations, and those short-term warm intervals are called interglacials. And the last of these interglacials, which we're currently in, is called the Holocene. Now, to risk bordering on pedantic, despite what is often said, the Ice Age didn't end when the Holocene started. We're still in an Ice Age, just in one of its interglacials. And a good thing too, because those periods are rare and they're much better for life. Ours, and just about everybody else's. And here's another thing you may not have been told. As you can see from the chart, the Holocene interglacial is colder than the previous 4 interglacials. So, even if today really were warmer than any point in the last 125,000 years, that's when the last interglacial ended, we're still in a relatively cool interglacial compared to the previous ones, whose temperatures were, of course, entirely natural. Humans were not producing CO2 back in those days. And one more thing. The Holocene has gone on long enough that based on the duration of recent interglacials, it might well be coming to an end. And if you look at past history, you see that when the world does go back into a glaciation, temperatures don't just fall hard, they fall fast. So, don't throw out your winter coats just yet.
And now, coming in at number 9 in our key facts about climate change you may not have been told, modern thermometers were invented during a little ice age.
Yes, and the reason this isn't just a historical curiosity, the reason it matters in this context, is that when we keep being told that such and such a year is the warmest on record, they rarely mention that the modern record began at the end of a period that's known to have been much colder than the present for reasons that have nothing to do with man-made greenhouse gases, and probably nothing to do with greenhouse gases at all. If thermometers had been invented by the Franks or the Romans, that record would look very different.
We know from proxy data that after the relatively mild medieval warm period, starting roughly 1,000 years ago, temperatures around the world began falling in the 1300s and didn't stop until about 1800. This was called the Little Ice Age. If you want to know more about it, check out our video, A Historian Looks at Climate Change. It was during this period that glaciers and polar ice grew to their greatest extent since the end of the last glaciation 10,000 years earlier, and Greenland became too cold and icy for the Viking settlers to remain. And those famous glaciers, like the ones in Alaska's Glacier Bay that have been melting since 1900, have actually been melting since 1800, or in some cases 1700, due to natural warming that seems to have continued to the present day.
Now, it was also during this little ice age that scientists learned how to make consistent temperature measurements. Around 1714, Daniel Fahrenheit invented the mercury thermometer, a big improvement on the alcohol-filled ones that had been created by the mid-17th century. Over the next 100 years, temperatures began being widely recorded for the purpose of keeping track of weather. So, the early temperature data coincided with the cold conditions at the end of the Little Ice Age and the start of that natural warming trend as we came out of it. But it was only a coincidence.
But even though mercury thermometers have been around since the early 1700s, it doesn't mean we have temperature records from around the world going back 300 years. Very few places have temperature data back into the 1800s, and temperature data from over the oceans is even more scarce. Which brings us to number 8 on our list. Over the past 150 years, there is temperature data for less than 50% of the Earth's surface.
And this data isn't just very incomplete, it's very unevenly spread out. We have decent early coverage for the continental United States and parts of Europe, but vast areas of Africa, South America, and Asia, other than Japan, Australia, and British India, have almost literally nothing until after World War II. So, when scientists make confident claims about this or that year being the warmest on record down to 2 decimal places, they are using a record in which over half the data is made up. And another thing, even where there is data, a lot of it comes from urban areas where the record is contaminated by the growth of roads, buildings, and other local heat sources and heat sinks, especially in the second half of the 20th century, airports. If we only use truly rural temperature records, there's even less data to work with. But, on the other hand, that data is more reliable.
Coming in at number 7, we have, for most of Earth's history, atmospheric CO2 was far higher than at present. And not just a little higher, 5, 10, even 20 times higher. Here's a graph showing estimated CO2 levels relative to the present over the past 500 million years. On this chart, our CO2 on the vertical y-axis means the CO2 level relative to the mean average of the past million years. So R equals 5 means 5 times the atmospheric CO2 level as the most recent period leading up to today. And MA on the horizontal x-axis means millions of years ago. So you can see that from nearly 600 million years ago to about 400 million years ago, the Earth experienced CO2 levels between 10 and 25 times higher than the very recent past. From about 250 million to 350 million years ago, they were close to the present, then went back up to between 2 and 10 times higher than the present. But about 150 million years ago, atmospheric CO2 began declining, and by the last glaciation had fallen to extremely low levels on the geological timescale.
That reconstructed data shows that CO2 fluctuates a lot for natural reasons, which are often not well understood. And obviously, we have no idea what sort of variations happened on a shorter timescale. The proxies don't pick up years or even centuries. But we do know this. The Earth's plant and animal life, including fish and other marine life, evolved under conditions with much higher CO2 levels in the atmosphere than we presently experience, even with modern-day CO2 emissions. And those higher levels didn't cause runaway disaster. On the contrary, the planet was lush with charismatic megafauna far larger than we see today. Moreover, the CO2 that we've added to the atmosphere in the past 50 years has been responsible for, or at least has coincided with, a remarkable worldwide pattern of greening and increased agricultural output.
Coming in at number 6. The famous 97% consensus only applies to the basic concepts, not to the claim of a climate crisis. Here again, we've covered this one in detail in an earlier video, which has had over 1.1 million views on YouTube.
So yes, it is safe to say that nearly all scientists agree that carbon dioxide is a greenhouse gas, by which they mean that it absorbs a narrow band of infrared energy and scatters it, and thus has a potential warming effect. And nearly all scientists agree that the world has warmed since the early 1800s, which, as noted, coincided with the end of the natural Little Ice Age. And finally, most scientists agree that humans do affect the Earth's environment, including potentially the climate system. So there's a consensus, but it's also where the consensus ends. Although they're often misrepresented by activists and politicians. The surveys that have been done among scientists show that once you start asking more detailed questions and more contentious ones, agreement quickly breaks down, including on the idea of whether climate change, whether man-made or not, is in fact a serious problem for the world.
One of the reasons why the consensus breaks down at that point is number 5 on our list. CO2 only has a small direct warming effect. Some people think it's simple physics that CO2 is transparent to incoming visible and UV light, but once that energy is absorbed by the land and sea and then radiated back out, CO2 absorbs, then scatters it, trapping some, and the planet heats up. But actually, climate model experiments where the CO2 level is doubled but nothing else changes only yield about 1 degree of warming over 150 years, as in this picture from a 1999 study in the Journal of Climate. To get the higher warming predicted by a lot of models, for instance, the upper line in this chart that shows 3 degrees of warming over the same time period, the simulations need to include complex, nonlinear feedbacks, especially ones where the fairly small warming from CO2 increases atmospheric water vapor, and that vapor, including in the form of clouds, then traps more heat, thus amplifying the initial effect of the CO2.
That means most of the warming in climate model experiments comes not from CO2 directly, but from hypothetical secondary feedback processes that are much more complex and uncertain than the itself complicated basic physics of CO2 absorbing and then scattering infrared radiation. It's far from settled what climate feedbacks even exist, let alone how strong they are. And, far from being in settled agreement, different climate models make very different predictions based in part on the assumptions about feedbacks that they incorporate. But, based on how little warming has been observed over the past 150 years relative to the increase in atmospheric carbon dioxide, many scientists actually believe that the Earth's climate simply isn't all that sensitive to CO2. Once again, we have a video on that topic, which has only had 75,000 views, so make sure you watch it and spread the word, because a lot of people could benefit from seeing it once they got over their surprise that they'd never been told about it. Just as they would benefit from knowing number 4 on our list.
4. The IPCC doesn't use the terms emergency, crisis, or catastrophe to describe climate change. Despite all the politicians who've declared a climate emergency and all the efforts to end debate by invoking the authority of the IPCC, or Intergovernmental Panel on Climate Change, this UN body that supposedly determines the science doesn't call climate change an emergency or anything else scary. Their most recent report on the science, the so-called 6th Assessment Report published in 2021, contains only one reference to the terms climate crisis and climate emergency. And it's in a section where they're talking about how some people in the media frame the issue.
As for climate catastrophe, it's not in the report at all. Nor is Code Red or Gates of Hell, we probably have to add, given the absurd rhetoric coming from the UN Secretary General when he's not busy signing condolences for the butcher of Tehran. Which brings us to our number 3 top fact about climate change that you're not supposed to know about.
Coming in at number 3, the IPCC denies a connection between greenhouse gases and most types of extreme weather.
Here we reach a large topic on which we at CDN have written many times, including in our IPCC Unspun series. But a good summary is in a Substack post by Roger Pilkey Jr. called What the IPCC Actually Says About Extreme Weather, where he shows just how much the apocalyptic rhetoric of activists has no foundation in IPCC reports. In debates on climate, once you get past everybody knows or simple dogmatic assertions that the weather's getting worse, you're again liable to get vague arm-waving about the IPCC and its reports. But in that post, Pilkey Jr. refers to Table 12 and Chapter 12 of the most recent IPCC science report. This is actual evidence based on data, folks. And in it they show, using color coding, which types of extreme weather have been linked to greenhouse gases already in their minds, and which ones they expect to be able to link by the end of the century. And if you've been listening to the conventional narrative, it's a surprising picture.
A white square means they haven't found a connection. Orange means there's an upward trend, and blue means a downward trend. A light-colored square means they have medium confidence, their way of saying a 50-50 chance that a connection exists. Only a dark color means better than a coin toss, in their view. As Pelkey Jr. points out, the IPCC has concluded that a signal of climate change has not yet emerged beyond natural variability for the following phenomena: river floods, heavy precipitation and pluvial floods, landslides, drought, all types, severe windstorms, tropical cyclones, sand and dust storms, heavy snowfall and ice storms, hail, snow avalanche, coastal flooding, and marine heat waves.
Well, that doesn't leave a whole lot, does it? And in most of these cases, they don't expect a connection to emerge anytime this century, no matter what journalists and politicians say, experts say. Just as the IPCC don't talk about a climate emergency, they also don't connect most forms of extreme weather to the fact that you want to heat your house, cook your food, and yes, drive your car, perhaps even on a summer vacation.
Coming in at number 2, most studies of the impacts of climate change are based on emission scenarios that are known to be exaggerated and implausible. The culprit here is an emission projection called RCP 8.5, which scientists frequently plug into their climate models when making forecasts of the effects of global warming this century. But as we explained in our video on the RCP 8.5 cheat, many experts have warned their colleagues that RCP 8.5 is grossly misleading and should not be used. It contains impossible projections of world coal use, and in the years since it was published, its predictions have already diverged from both actual fossil fuel use and emission trends. And in both cases, the predictions were well above observed data. Yet thousands of journal articles and news media reports still get published each year telling catastrophic stories based on RCP 8.5. You can pretty much guarantee that whenever you read a headline about some terrible calamity that will happen in the future under global warming, if you hunt through the footnotes and hyperlinks, you'll find that it is based on this impossible emissions scenario that many experts have long dismissed as unrealistic and biased.
And that scenario's recent makeover as SSP 8.5 doesn't make it better.
Finally, coming in at number 1, climate models warm too much at the surface and in the atmosphere.
It's an established fact. No, not that the models have predicted past warming and can be trusted, that they're overheated and overwrought.
The following diagram is from a peer-reviewed 2023 study, which groups the latest generation climate models into those with low, medium, or high sensitivity to greenhouse gases, and compares their predicted warming since 1980 with 4 different global temperature data sets. Yellow is what they predicted, black was what was measured. Only the models with the lowest climate sensitivity matched the post-1980 historical warming record. The others predict far too much warming compared to what actually took place. And as the author of the study notes, therefore, the projected global climate warming over the next few decades could be moderate and probably not particularly alarming.
The weird thing here, or one of them anyway, is that normally scientists propose a hypothesis, check it against data, and then revise it so that it fits the real world better. But here it's the reverse. The more the models bungle, the more their designers make them worse.
A 2020 peer-reviewed paper showed that all 38 of the latest generation CMIP6 climate models from around the world overestimate observed warming in the global troposphere, in most cases by a statistically significant margin. The only place where progress was made, or at least regress avoided, is that again, the models with the lowest climate sensitivity were found to yield historical reconstructions closest to the observed trends.
Which brings up a point that's so important that we'll stretch our top 10 list for it. Yes, folks, this one goes up to 11.
If climate sensitivity is on the low end of the model range, economists have shown we shouldn't waste money trying to stop global warming.
Once you get rid of the exaggerated emission scenarios, the climate emergency rhetoric, and the overheating models, and instead focus on actual climate data and realistic estimates of climate sensitivity, the numbers show that climate change is not a crisis or a catastrophe, and even if it will cause some problems in some places in the decades ahead, it would do far more damage to society to try to stop it or slow it down by getting rid of cheap and reliable fossil energy than it would by simply learning to adapt and live with it. So, that's our top 10 plus 1. And all these things are so important to the debate and to our policy choices that it's nothing short of a scandal that they have been so completely excluded from the conversation. Let us know in the comments what you think of our list, including whether there are other things that you think we should have included and why. For the Climate Discussion Nexus, I'm John Robson, and that's our fact check on the top 10 facts about climate change that you probably haven't been told, but certainly should have been.